Thank you so much, guys.
Can you see my screen?
Yes.
Yes.
Excellent. So I'll just go to the agenda part. All right. So agenda, we will initially, we are having the introduction part anyway now. Then we will go to, we will start with the, overview of Runtime Fabric. We will touch base upon, both flavors of Runtime Fabric, the Runtime Fabric Appliance and also Runtime Fabric on self-managed Kubernetes, where we are going to, do our demo and stuff. We'll also, cover the benefits and feature comparison of, RTF on self-managed Kubernetes, especially compared to the other deployment models like CloudHub, or even within the RTF, compared to the appliance model. We'll then go to the demo side. So we are going to mainly focus on the demo side of things today, because I've seen lately a lot of meetups are covering this particular topic on Runtime Fabric, whether it is self-managed Kubernetes or the original appliance. And a lot of them have been mainly around the theoretical side of things, covering, a lot of features, functionalities, and stuff like that. I want to actually, mainly do, on the practical side of things, doing the demonstration, showcasing the features and, functionalities. We'll start with, RTF installation. Then we will actually cover the deployment of application into the Runtime Fabric. We will touch base upon, log externalization, the auto-scaling feature, behavior of the scheduler, how it works within the Runtime Fabric. Then, if time permitting, we will also cover API Manager and TLS termination, all these as part of the demonstration. Then the last section would be there will be a Q&A session. You can ask questions now after this demo, and then there will be trivia, quiz, and networking time after that. So that pretty much, concludes the agenda. Now, yeah, before moving into Runtime Fabric overview, I'll just actually, want to touch base upon the different deployment models. All of you must be already aware of that. But before running into the Runtime Fabric deployment model, let's just try and understand, how many deployment models do we have in MuleSoft. We have majorly around 4 deployment models covering, starting with CloudHub. So CloudHub is mostly like an integration platform as a service, pure integration platform as a service, where both the runtime plane and control plane, it's actually, managed by MuleSoft, and you deploy the applications into CloudHub, basically, which is in the backend, AWS cloud. Now, the second deployment model would be your hybrid model. Hybrid model is basically your control plane would be basically managed by still, MuleSoft. You have your Anypoint platform, Runtime Manager, and API Manager, everything running in the platform, and the runtime plane would be hosted by customer, either in a data center, bare metal server, or even in their own private cloud. So this particular model, hybrid model, has certain limitations compared to the CloudHub model, like load balancing, high availability, automatic failover, rolling upgrade. These features are not available out of the box. You will have to provision. Customer will have to provision those services on their own. Now, there is actually a third model, which is deployment model, which is private cloud edition. Certain customers would need their control plane and runtime plane, hosted, in their own cluster environment, in their own, server environment. And for that, this could be due to, regulatory issues, compliance issues, stuff like that. So they want even the metadata to be, residing in their own premises. So there you have private cloud edition. And then enter Runtime Fabric, which we are going to cover in this presentation. So with Runtime Fabric, what happens is that you have you basically actually deploying the applications into containerized modules. So basically you have your Mule runtime and applications both deployed into containers, and they will be deployed into any of the cloud or on-premise environment. There is support for AWS, Azure, or your own data centers, any data centers, So these are all supported in this flavor. So the benefit of why you would want to go to Runtime Fabric. So it is actually a middle way between I would say, cloud up and the hybrid model, whereby with some of the features missing in the on-premise model or hybrid model, you have those available in Runtime Fabric, like the features I mentioned before, like load balancing, high availability, automatic failover, rolling upgrade, just to name few of those features. So again, running through the benefits, it can deploy consistently across any cloud or data center. So those are actually listed here. Then you have you have the benefit of running multiple runtime versions in the same runtime fabric. Now, when it comes to hybrid model, there is this limitation that whatever mule runtime running on your server, all the applications will be deployed to that, and all the applications will be running on that particular runtime version. Now, with Runtime Fabric, you are actually deploying application into containers along with the mule runtime. So that means you can actually choose the mule runtime. Sometimes there would be requirement to run the old mule, so existing applications probably would be running on old mule versions before 4, like 3 point something. So even those would be supported under Runtime Fabric. All right, so the other two features there I've already discussed. The scale horizontally, which is basically about the high availability and redeploy with zero downtime, automatic failover and stuff like that. Control plane management in the Runtime Fabric scenario is like cloud up or on-premise, where it is actually done through Anypoint platform. So all your application deployment, managing, little bit of monitoring, all this stuff actually can be done through, even policy applying, everything can be done from Anypoint platform, which is your control plane. All right, so let's get to the different flavors of Runtime Fabric. We have two flavors of Runtime Fabric. One is actually the original and traditional version, which is actually Runtime Fabric Appliance. And the other one is actually what's shown here, which is the latest one, self-managed Kubernetes. So we'll start with Runtime Fabric Appliance. Here, what's happening is that customer only needs to arrange the infrastructure side of things. Kubernetes and Docker, those all will be managed by MuleSoft. They will actually provide and package it and provide to to deploy. So this is actually more like software service sort of things. So if you look at here, so this Runtime Fabric Appliance, this is actually this plus Runtime Fabric components. This constitute the whole Runtime Fabric Appliance solution. Now, to run this Runtime Fabric Appliance, there will be additional master nodes needed. So these are actually here worker nodes where your applications will be deployed along with the mule runtime. But then there is a master node running in the background, where all the Runtime Fabric Appliance components will be running and doing all the the controlling or managing stuff. So that's basically the control plane. Now, the benefit of Runtime Fabric Appliance, you have load balancing and log forwarding stuff provided out of the box, and these set of servers are actually supported. Now, going further into the Runtime Fabric on self-managed Kubernetes, which is actually the latest flavor. So the control plane is sort of managed by the self-managed managed Kubernetes providers like Amazon or Azure or Google. So this part constitutes the control plane or master nodes scheme of things, and these are actually happening in the background, so you don't need to worry about that. Those things would be managed by the service provider. Now, so this one is actually delivered to customers as a package. So basically the services and other the Docker services and stuff are delivered to customer, but the Kubernetes, like I explained, that's actually the responsibility of the customer, or to be precise, the service provider. Now, here customer maintains the health of Kubernetes. So obviously you need to have some sort of IT ops expertise to run and manage the Kubernetes, maintain the Kubernetes, obviously with the security side of things and other aspects. You also need to, compared to the appliance we saw before, there are certain features missing. So you need to provision your own Ingress Controller and log forwarder solution when it comes to the self-managed Kubernetes solution.
Shefreen, just a pause. Sorry to cut you. So we have two questions. Okay, so I don't want to miss that context. Okay, so The first questions we have is, does the virtual private cloud deployment model is managed by MuleSoft?
No, it will be managed by customer. So MuleSoft obviously, provides the related resources and everything, but the management is actually, up to customer.
Yeah. And we have one more question. So can you elaborate on log forwarding?
Yeah, so we are going to cover log forwarding in the upcoming slides. So when it comes to Runtime Fabric Appliance, it's provided out of the box. So you don't have the option of, or you don't have the flexibility to use your own log forwarding solution. But in our demo, we are going to cover that. I'm not going to, install the log forwarding. That's something already installed. It's ELK stack, but actually I can show you around where how we can monitor logs, how we can monitor metrics. All those things are covered in the demo.
Yeah. So yeah, one more question is this. So I'll answer that question. Is the Cloud Hub is only managed by MuleSoft? Yes, we know that is the only runtime managed by MuleSoft. Okay. And Shefreen, I have a question for you. So we talked about load balancing, right? So is that the load balancing we're talking about internal load balancing, which is like VMs and all, or we're talking about the HTTP load balancing?
HTTP load balancing.
Is this
the one which we have to provision, that will be HTTP load balancing sitting, just at the boundary of your, Kubernetes cluster.
Yeah, ingress traffic we use that, right?
Yes, so it will be sort of, linked with an Ingress controller. So you have the load balancer, and then, that will talk to the Ingress controller, and then, up ahead with the services and applications and stuff like that.
Okay. Yeah, go ahead. So those are the questions.
Sure. All right, thanks for the questions, guys. We will move on with the benefits of, Runtime Fabric. Now, the benefits actually, the first and foremost benefit, this one is not specific to RTF or EKS, but Runtime Fabric, as compared to, other deployment models, especially Cloud Hub, it's actually cheaper to run Mule applications on Runtime Fabric. One reason being, you could see here, there is actually dedicated master computing instances, master nodes required for, this Runtime Fabric Appliance part, where all the control plane is actually being, handled. Normally that would require at least 3 nodes, with good memory and, good computing power. So that can actually, cost, if it is a cloud, obviously it can cost, a couple of $1,000s per month. But when it comes to self-managed Kubernetes, this is actually, sitting behind the scenes, and it's managed by these cloud providers, Amazon or Azure or Google, and Amazon actually charges only how much, $0.1 per hour for that service, while Azure and Google actually it's actually providing it free of charge even. So you only pay for the worker nodes. You don't have to pay for the master nodes. So that's actually one way of actually being cost effective. And then the other thing is, when you deploy the applications, when it comes to Cloud Hub, there is, you all know that it's a minimum of 0.1 vCore, right? 0.1 vCore, and with a base subscription of 2 vCores, what is the maximum actually, maximum number of applications you can deploy? 20, right? So that's basically about it. But when it comes to Runtime Fabric, you can actually deploy application with as low as 0.02 vCore. And the benefit of this then is you can actually go all the way up to, theoretically all the way up to 80 applications for the same vCore license. So for an organization running, hundreds of Mule applications, obviously this will be, much cheaper compared to the Cloud Hub option. Obviously, you will have to pay for the computing resources and all, but overall, if you do the maths, it still will get to be cheaper. The other benefit is flexibility. You can actually choose your own Kubernetes provider rather than actually going with the appliance provided by MuleSoft, which is actually gravity based. Here you can actually probably you have in your organization already Google Kubernetes service, or Amazon Elastic Kubernetes service, or Azure. So you can actually go with whatever is available in your in your organization. So that flexibility is there. And the other thing is operation teams have control over your Kubernetes domain, while in the appliance, you don't have, because that's actually completely provided from MuleSoft side. So also less overhead, as these are actually all highly available and managed by respective cloud providers. So you don't have to worry about the control plane or upgrades or all the Kubernetes related upgrades and stuff like that. So that's all managed by the respective providers. And then there is auto-scaling and node groups feature, which actually helps to drive down the cost of infrastructure. Reason being, you can actually have the node group configured with probably minimum number of computing instances, and scale up automatically whenever it is required. So more applications deployed in your cluster, it will auto scale. It will add worker nodes automatically. So that way also it's less overhead in terms of managing the worker nodes and stuff like that. All right, now just before going into our demo section, just a quick run through the solutions feature comparison. So here we have Runtime Fabric on self-managed Kubernetes, and on the right-hand side, it's Appliance. So as we discussed, everything actually, we discussed before, but, just summarizing it into one table. So Kubernetes and Docker, customers bring their own, Kubernetes via provisioning either of these providers. MuleSoft actually supplies Docker images, which is basically the Runtime Fabric, Dockers, and, whenever you deploy the applications, obviously that is also coming from MuleSoft. Now, RTF Appliance Kubernetes is actually, Kubernetes and Docker both are actually already included out of the box. Linux distribution, self-managed Kubernetes supports all versions, while RTF Appliance only supports these Red Hat and CentOS version only. Node auto-scaling, this is actually a big plus when it comes to RTF on self-managed Kubernetes. This is not actually available in Runtime Appliance, the traditional Runtime Fabric model, but it's actually something you can configure through Azure or AWS or Google auto-scaling configuration. So we will actually do we'll cover this as part of our demo, where we can see the nodes sizing up or down, basically up sizing from 2 to 3 nodes. External log forwarding, you can provision your own. So you have the option of going with ELK stack or Splunk or your own actually logging, any logging domain you want to go with, you have that option. And with RTF Appliance, you'll have to go with whatever coming out of the box. Internal load balancers, you have to set up your own Ingress like Nginx or HA proxy, or there are various actually third-party Ingress providers there, Ingress controllers there. You can actually provision them along with the load balancer, and in RTF Appliance it's already included like mentioned here. One drawback, security, Anypoint security edge, it's not supporting not supported as of yet, but you can actually have your own security. I mean, chances are obviously, you have your IT team or IPsec team doing that security, all the best practice security configurations. But obviously with RTF Appliance, a lot of, security features are available out of the box. So yeah, that's one feature difference there. Ops Center, that's mainly from a monitoring and alerting point of view. RTF Appliance, it's included out of the box, though here you can have it through your AWS or Azure or Google GKE console. So yeah, so I'll take a pause here because we are going to start with the demo side of things after this. So any questions after that you would want me to answer, Ashish, or I can't see Anup.
Yeah.
Hi,
so
go ahead, Ashish. Yeah.
Yeah. So yeah, Shefreen, we don't have any questions as of now. We can go ahead.
Excellent. So let's get to the demo side of things. Now, when it comes to the demo, let me show you this. So we are starting with Runtime Fabric installation. So this actually have some prerequisites. Now, when I say prerequisites, that covers obviously your AWS EKS cluster needs to be created. Then, sorry. Then there is Ingress Controller configuration, logging framework installation, and auto-scaling. So these are all have already been done, because if we were to cover all these topics as part of this presentation, that itself would take probably an hour or so. So that was actually beyond the scope of this presentation. But I will quickly run through the cluster, starting with the cluster. So I should have it here. So this is actually the EKS cluster. So you go to AWS console and then go to clusters. You have this, I have this cluster created, NJC EKS cluster demo. Now, so whenever you create a cluster, that's basically your control plane being generated, basically the master worker nodes, master nodes actually in the background, which AWS is going to manage. You don't have to worry about it. What you do is you actually do node group configuration, basically adding worker nodes as a node group into the cluster, right? Now, there is actually a lot of documentations available, how to do these configurations. And also, if you want to get your hands dirty, please feel free to, go ahead and do it by yourself. And I also might be sharing probably a few blogs, related to all these prerequisites, and I'll try to, upload that as part of the slide pack, or somewhere in the link where we will be uploading the slides. All right, so node group configuration, few points about that. You can see that the node groups have been configured with T3 medium, so that's basically 4 GB memory, if I remember correctly, and 2 vCPU, and I have this 50 GB hard disk. Even though for a production, scale deployment, the recommended one is, this is for demo, so I went with a smaller one. But production scale, obviously, MuleSoft recommended requirement is 16 GB of RAM and 250 GB hard disk, and vCPU is 2 vCPU is still enough. Now, for auto scaling, I have the minimum size configured as 2, desired size is also 2, maximum size is 4 nodes, 4 EC2 instances, maximum it can scale up to. So this is actually related to horizontal scaling. You also can do the vertical scaling, where it would actually involve changing or upgrading from T3 to other high memory sizes or high computing instance sizes. But yeah, we are going with the horizontal scaling for the demo. All right, so I'll just show you. So here we saw in the overview, so these are actually the 2 worker nodes available. I'll just show you here. So in the console, we need to install kubectl, which is actually a command line interface tool to manage the Kubernetes remotely. So that has all, again, that's one of the prerequisites. I have already done that. And so I'm going to show you, when you do kubectl get nodes from the command line, you're going to see the same computing instances you have seen here. It's the same here. And then other thing I want to show is existing, ports. Ports are basically, the resources where the applications will be deployed. So now these are actually all the pre-existing or prerequisite related ports. So this metric beat, file beat, these 2 are related to our ELK logging framework I've already installed. So what you do is you have these will sit on each of the nodes as a daemon set, and it will collect all the logs. The file beat will collect all logs, and metric beat will collect all the metrics, basically performance related metrics. And you can actually, when you install this, you can configure it so that it will be forwarded to a to Elastic Cloud. So I have Elastic Cloud. It's actually available. 14-day trial is available, free trial. So you can actually, just go ahead and then, try with that. Most of you would be already aware of, ELK. So I already have under Discover, I'll just show you, I already have the file beat and metric beat detected, or forwarding the logs here, file beat and metric beat. So this has been added as index, and everything is set for our demo. And the other things installed is Ingress Controller. So there is what I have chosen is Nginx in Ingress Controller. So that will, when you install that, that will actually have also the load balancer installed. So this load balancer will work as your entry into your cluster. So any client wanting to wanting to communicate with your application, that will be routed through or load balanced and then routed through your the network load balancer and your Ingress controller. So it doesn't have to be Nginx. Say there is actually a lot of other Ingress controllers available out there. All right, the last one I have done, the prerequisite is cluster autoscaler. So there's a proper documentation available in AWS. So you just need to, you can actually do it by going through the documentation with proper IAM permissions and stuff. You install the cluster autoscaler. This is actually the component which actually scales your worker nodes up or down depending upon the requirements. All right, so we are done with our prerequisites. Now we can start with the second.
Shefreen, one question. So this kubectl utility, I think you might have configured with AWS, right? So it's going to, it's connecting to your environment and it's pulling the data from there, right? Metadata. And then,
that's right. That's correct. So you install it and then you have to actually provide proper permission and then that's it. You have to actually configure it with your secret key and stuff like that, a token and stuff like that. Okay, so sorry. So we'll start with the Runtime Fabric installation. So one last prerequisite, that is actually RTF-CTL. So RTF-CTL is the command line utility to install, manage, and manage and maintain the Runtime Fabric. So that's available in the MuleSoft documentation. You just need to download it and then that's good to go. So I have it actually up and running, and we will start with the Runtime Manager. So this is actually the platform account. Go to Runtime Manager, go to Runtime Fabrics, and what you have to, the first step to install a Runtime Fabric is to create a fabric in the platform under Runtime Manager. So you give it a name. So I'm going to give it RTF demo EKS. So all these different flavors are available. You have AWS, you have Azure, this Google Kubernetes engine we talked about. This is actually a latest addition, probably last month only they have added it. This gives more flexibility actually, with free credits and all, this is the one which you may want to get your hands dirty on. Then VMs or bare metal, this is the traditional appliance model of Runtime Fabric. We'll go with EKS. Now, go to next, accept the support responsibility. And that's it. This is offline. Nothing has been installed in your Kubernetes cluster. That has to be initiated from the cluster. We are going to do that. What we need to do is we need to get this key. I'm going to copy the key soon. Let me just get we'll start with the validation of the environment. So RTF-CTL, sorry. Give me a second. Let me copy the command. Okay, so RTF-CTL validate. So we need to validate the cluster by providing this key. Copy that. And this will ensure the cluster is having all the prerequisites met in terms of whatever you can see there, namespace, secret read-write operations, cluster role binding, all these different the overall resources available in terms of CPU capacity, memory. So everything will be checked, and it will also check the connectivity to the control plane of MuleSoft. Anypoint control plane it is actually checking. So all is good, all validation successful. So we are good to proceed with the installation. So for installation, the command is RTF-CTL install. I had this force reinstall also because I have some permission related issues, but normally that is not needed. But if you face some issues with installation, you can actually just add that command. Now again, you will need the key there. and that should start the installation proceedings. So what this is doing is actually installing all the required services, pods, Ingress configuration, everything required for your runtime fabric. So there are a lot of checks again being done, and then waiting for runtime fabric to become ready, so we can actually monitor the status here. Currently it's still offline, but soon, probably when this hits almost closer to 60 seconds, this should start becoming active.
Yeah, so Shefreen, please share this command. So we'll upload with the slides.
Yeah, sure. So I don't have those in the slides, but I have it maintained in a separate document, so I will share the same.
Yeah, that document plus the references which we have used.
Yeah, sure. All right, so runtime fabric is ready. Just ignore this command. But runtime fabric is ready, but yeah, registered. Let's just see. This needs to be green. So let's just. In the meantime, while it gets ready, we'll just check for all the additional components installed. So all these services or additional ports have been installed as part of the RTF. Initially, we only had this much. So these are actually all the additional components actually installed. All right, now we also need to install the license. Yeah, so this one is actually active now. All systems operational, it's healthy. We are good to go there. The next step actually, is there's no license now. So even though this is ready, if you deploy an application, try to deploy an application to this runtime fabric, it's going to fail because application will not get deployed without the license. So we need to upload the license. So license, your organization should be having the license. If not, you can also, get a trial license, 30-day license as you get for, the on-premise server, trial. Similar to that, you can also get it for runtime fabric also. So I have and it needs to be base 64 encoded. So I have that already prepared here. So I'm just going to copy that. All right, so this is actually the license, base 64 encoded license we are applying. Let's see how that goes. So we did the validation, installation, licensing part. Okay, so license updated. We can check the validity of, or if the license has been updated or not with another command, which is get new license. So that will actually show the same license key just to make sure that, that has been uploaded. So we are good with that. Now we need to do Ingress configuration. So this is actually the runtime fabric environment. We can actually start configuring the environment. So this one is not related to any business group or any environment yet. So what you need to do is you need to select the environment where you need to relate this runtime fabric to. You can also choose other business groups if that is required. But for the demo purpose, we have this under this particular business group. So we are going to stick to what we see here, sandbox and apply. So this is going to so now you can start deploying application to this runtime fabric, but there is one more step, couple of steps, before that. One is actually inbound traffic. So currently there is no way to communicate with this runtime fabric because we need to link up the runtime fabric with the Ingress controller and network load balancer. We saw that before. So I'm going to, so under get service, kubectl get service all namespaces, that will give you all the active services running. So there is all these RTF related services running after we install the Runtime Fabric. Otherwise, we had these existing services, and as part of the Ingress Nginx controller, you can see this external IP. So you need to copy this, and you need to configure that as an endpoint here. So let me get that. All right, so add endpoint. So we'll start with this network load balancer address. I know this is not user friendly, and this is not how you would normally configure. We have a custom domain, so later we will come to the custom domain part, where instead of this, we'll just configure a user friendly custom domain. But that will be at a later step. So save and deploy. So we are almost good to deploy the application, except we need to configure the Ingress controller. So give me a second. I just want to show you. So this is how your cluster along with the load balancer and Ingress configuration looks like. So you have the Ingress managed load balancer, which I showed you just sitting here. And that actually gives you entry point into your Kubernetes cluster. So you have your Ingress controller, which routes the traffic to services, which are basically, your application, whatever application you deploy into the ports, they will actually communicate through a cluster IP service, right? So in order for the Ingress to reach out to the service, it needs a proper Ingress configuration. The out-of-the-box Ingress configuration doesn't provide that. So there is a template available from MuleSoft website, and you need to do some small change or configuration to that. That is basically to rewrite the target, and also the rules needs to be modified so that it can actually communicate the proper path. Now, this has already been done. So what you need to do is you just need to run the command for the same. After this step, we are good to go with the application deployment. So this will make sure that proper Ingress rules are available for the RTF modules to, write it to back into the Ingress resource. So without this, the Ingress rules would be wrong, and you will not be able to reach the endpoint. So that's also done. So now we can actually, just deploy a Hello World application and see how it works. All right. So for deploying application, you go to applications, deploy application, give it a name. I have a predefined name so that I can track it in our logging framework. Already some dashboards have been created. That's the reason why. Give me a second. Let's put the name. RTF demo hello world. We deploy it into our EKS cluster. You upload the file. So demo RTF hello world. It has already been. It's higher in size because it has also got the specification and interface for, if time permitting, I said, the API manager and policy applying. So for that reason, it's a bit large on size. Might take a while, and in the meantime, I will take questions while it is being uploaded. But we need to discuss few parameters. So runtime version, like we discussed, you can choose whatever runtime version you want. Obviously, if it is a zip, any version before 4, it needs to be zip file. That's why it's not disabled. I mean, it's not active. So we go with the latest version. Replicas. This is actually to how many ports, application ports you want to, or how many replicas you want to create. So one means there is no high availability scenario. In that case, you need to actually have at least 2 replicas for high availability. And other features. So we will go with 2. Currently, our worker nodes are 2, like we seen before.
Shefreen, meanwhile, we have a question. So where do you place that YAML file in the Ingress config?
You need to apply that into your Runtime Fabric. So what you do is, with the command actually I run, what it does is, so this command rtf-ctl apply. All right. So this is already in my local machine, that file. So when you point the file name, which is ingress custom.yaml, it's actually already located in the same folder as this. So you apply this configuration, and it will automatically be taken uploaded into the Runtime Fabric.
Okay, got it. Yeah.
Yes, Shefreen, one more question. How Mule apps authorized, okay, in Mule Studio get published to EKS or EKS RTF? That is what the question we have in chat.
Sorry, can you repeat that
How
again?
would Mule app authorized in Mule Studio to get published to EKS RTF? So I think the question, I think let me remodel this question. I think from the Anypoint Studio, how we are deploying to Cloud Hub, right? Is there a way to deploy to RTF?
Oh yeah, no, yeah.
I think that is.
I got it. No, not at this stage, because if you look at the studio, the options are only to deploy to Cloud Hub. Even at this stage, you can actually, even though deploy through Maven commands, that is possible. But through Studio, it's only the Cloud Hub, because that's only configuration. You have authorization, right? So not to the Runtime Fabric yet. Probably in future they might come with this. Or I'm not sure if Bijoy knows more about it, if there is any feature currently available. To my knowledge, it's not yet
there
available.
might not be in the direct, like a link in the studio, like you cannot right click and do, but maybe what you could do is go to the POM file and change the Maven setting and add the configuration of Runtime Fabric, and a Maven Mule deploy should be able to do that.
Yeah, Sanchit, is that the answer to your question? Please give us a check mark so that we. Okay. Yeah, satisfied.
All right. So yeah, so the replicas run in the runtime cluster mode. That's actually similar to what you have in hybrid model, where you have you without this there will be resource contention, means files or other services actually could could have resource contention. It can actually duplicate. Then there is a scheduler will actually run on all the replicas without this feature being enabled. So obviously you will want to go ahead with this cluster mode. And then also deploying replicas across nodes. So we have 2 nodes. That means both replicas will be deployed into each of the worker nodes. We'll go with 3 at this stage, because we also want to demonstrate the node auto-scaling feature, right? So for that, I want to actually utilize maximum resources in terms of memory. Deployment model, you have rolling update and recreate. Recreate means that any update to the application, it will delete the existing replica and create a new one. But if it is rolling update, it will actually the new replicas will be created at the same time the old replicas are still available, taking the traffic, and only after the new replicas are created, the old one will be deleted. So you would also want to go with rolling update, because that gives you that
zero downtime.
Zero downtime and failover features and stuff. All right, so we'll go with, okay, so reserved CPU, this we already discussed, 0.02, while in Cloud Hub it's actually 0.1 minimum vCore. So this is actually where you get to deploy a lot of applications with if you go with the reserved CPU of minimal value. CPU limit, so let's say you have you have free space available in your worker node, and free space in terms of, not free space, I had to rephrase it, free CPU credits available in your worker node. And even if you are reserving it to 0.02, it can burst. There could be some burst scenarios where more CPU utilization or CPU credits are required, and for such cases, this can scale up all the way to one vCPU, provided it's actually available in the worker node. So this is also a useful feature. Memory, the minimum is 700 MB. You can we will go with 0.8 just for the sake of, again, like I discussed, to demonstrate the auto scaling feature soon. All right, now the other configuration, Ingress, this is actually, we already configured in the Runtime Fabric, so you just need to select that. And I believe that's pretty much it. You can actually deploy the application.
I just noticed that when you make a replica 3, the other checkbox is getting disabled.
Yeah, that's right. So that's actually, when it is 2, it is there, because you need to have the exact you need to select the exact replica number as the worker nodes. Currently, as I shown you, it's only 2 worker nodes, right? So it will be deployed into those 2 worker nodes. When it selects 3, it cannot equally distribute. So that's the reason why it is disabled. Now, probably after auto scaling, when the worker nodes gets to 3, when you select this 3 replica here, this will be enabled. I'll show you that when it comes to our next application deployment. All right.
Okay, one more question we have, Shefreen, before moving to the next slide or next step.
I'll just deploy the application, so that anyway that's going to take time.
Yes, so Sanchit had one question. Since Ingress is managed by AWS, does this mean that Anypoint security profile would not be used?
Yeah, so that Anypoint security, that edge policies cannot be used in this part, in this kind of deployment. That's right, Shefreen?
Yeah, security edge anyway, this one doesn't support, but other securities related to API manager, whatever you use, policies and all, that's actually perfectly possible. It's only the edge security features that some fancy edge features available as part of security, which is available in the appliance model, unfortunately not available for managed Kubernetes service. But like I said, API manager policies and all, they are all available. No restriction to that. All right, so let's just see where we are with the application deployment.
Sanchit is saying that it's like putting a Bentley engine inside an Alto.
All right, so yeah, so this one is actually getting deployed. We can actually see the progress even from here with the kubectl commands. Check the ports, application ports, and see, these are actually the new the 3 replicas being created for our application, RTF demo hello world, with actually the port identifier. Now, so this number here, 1 out of 2. So these are actually the number of the right hand side is actually the number of containers within the pod. So there are 2 containers. One is actually the application container itself, which is yet to be installed, and then the other one is actually the Anypoint monitoring. So even the logging is not available out of the box, the monitoring is available. So we will go to Anypoint monitoring after this, where all the some resource statistics and endpoint number of API requests and everything we can actually see there. So so whatever installed there is actually endpoint monitoring, but application is still getting deployed. Let's see what is the progress. Yeah, it's deployed, and we should be able to see that here also. Desired configuration applied successfully. All good with that. Now, hopefully, fingers crossed, when we so this is actually the endpoint. So how the URL works is, or the endpoint works is, the URL for the deployed application would be your custom domain or your network load balancer address / the application name. All right. Now this one being a this application also has an interface with specs. So that means the endpoint would be /application /API, and the actual endpoint is test. So let's just see if we can get the request. Yes, so message hello world. So the application has been successfully deployed, and we are getting the response back. So this application is deployed. Now we will go to the next part of our demo. So hello world application deployed. Now let's just see what's happening in the Anypoint monitoring. I told you that there is Anypoint monitoring module, or the pod actually installed within the or container installed within the pod. So let's just see if we can see the stats from the Anypoint monitoring dashboards, built-in dashboards. So yes, so this is our application. environment is sandbox. Let's view it, and let's just give some more hits from our client here. We will see the monitoring, not just from Anypoint monitoring, but also from our custom logging framework, which covers the logging and also the metrics also there. Now, see this. This is actually, you can already see the stats related to, CPU utilization, thread counts, memory, and stuff like that, and also at the overview. See, this is the inbound request, it has received mule messages. So all those statistics are getting populated. So that's good. So it is successfully communicating with the Anypoint monitoring. Now let's just go to our custom logging framework part. So like I said, we are using a Elastic Cloud ELK stack, even though Logstash is actually not being used. It's mainly the Kibana part and, Elastic for log collection. Now there is the dashboard. I already created a dashboard, so that should show you, sorry, dashboard. Dashboard is in Kibana, and okay, that's just last 1 minute. Probably I need to update it. See, so you can see the request within the last 2 minutes coming to all 3 different pods. So you can see this is also round robin in the sense that when you send one request, the first request will pass to one of the replica. Yeah, so this one came to Z7TJS, which is actually this one. Now let's just send 2 more. And let's see, where are they hitting? Can take few seconds for it to reflect. Yes, so first was this, then actually it went to the next pod, and then finally the third one. So all different, it's actually doing that round robin. So every time a new request coming, the load balancer will forward it to each of those replicas. So that actually also covers the load balancing verification. But as part of the logging framework, there are more to cover. We can actually see the logs. So as of now, we don't have any logs. There is no logs out of the box, logging framework out of the box. So here I can show you. So these are all the requests, coming, captured. So the file beat sitting inside the cluster, it's actually forwarding all the logs. This has already been filtered to specific to our application, and also because there are 2 containers, application and Anypoint monitoring, we have specifically selected app container, and so that's actually will show you all the logs. Now, if you expand on that, there are a whole bunch of information regarding the infrastructure details, the service provider details. There are a lot of information, and there is a lot of possibility to make custom dashboards and other stuff with all those information. So that's actually up to individual organizations to see what to do with that. Now the other thing I want to show you is metric side of things available in ELK. You go to metrics, and so there is an inbuilt app available in the Elastic ELK stack. So with metric, you can see, so this is actually the 2 worker nodes. We have 2 worker nodes, like I have been showing all this all along. So this is actually the CPU usage for both the worker node 7.4 and 7.5. You can also see something related to memory usage, 36%, 57%. Then you can also see pod level information where, so these are actually our application. These are other existing services. This is actually our application RTF demo. 1, 2, 3, right? So just click on one of them. You can go to individual pod level metrics. So there are additional metrics. What I want to show you here is a lot of additional metrics available on top of whatever we can see from Anypoint monitoring. So all these fancy graphs are available. Now, so that sort of covers the logging framework, but there are other options also available. You don't have to stick to ELK. There is Prometheus and Grafana, along with Loki Tail. There is actually, for log collection, there is Loki Tail, I believe. So there is that solution. You can use also Splunk. Various solutions are there. So that's totally up to you. Which one to go for. Now, let's move on to the next. So we have covered this much of the demo. Let's go with the auto scaling feature. So as part of that, what I'm going to do is so when we configured the network load balancer inbound traffic address here, I said that there is also an option of custom domain, right? So we already have a custom domain. This particular custom domain, ngclabs.net. So there is a type A record already created in Route 53, which is actually a DNS service available from AWS Amazon. You actually, created a record mapping your custom domain to, network load balancer. So this is the same network load balancer we are using there. So that's already been done. So what we can do is straight away configure this as the custom domain. So let's go ahead and do that. So you will have to do that in the inbound traffic of under the Runtime Fabric section. You delete this, add an endpoint. Oh. Bear with me. Any questions? You can actually mention that. I just have to, yeah. So add endpoint https ngclabs.net. So now we are going to route our traffic to this custom domain instead of the actual network load balancer. So add endpoint, save and deploy. Now here, this has been updated in the Runtime Fabric, but the application, it will not get updated into the application. You will have to redeploy the application. So go back to application and under Ingress, it's already populated with ngclabs.net, but you need to apply the changes. Now, when you apply the changes, that zero downtime feature, we can also, touch base upon that, and also the autoscaler feature also should be visible now. So you view the status. You see, these are the existing replicas. Config last successful, the last time application we deployed, and this is actually the new one. So 2 ports are getting, initiated and deployed, but this one, third one, it says unschedulable, zero, 2 nodes are available, 2 insufficient memory. So this particular one, it's not able to schedule it because of resource restrictions within the available worker nodes. So that's where actually Autoscaler is going to kick in. And that's actually a very powerful feature, which is not available in Runtime Fabric on Appliance. So we can actually see what's happening here. Get nodes. It's still 2. So right now it should be able to kickstart anytime soon. In the meantime, let's just look at the ports. You see this. This one is actually still pending. So this is where actually, and the other 2 has been deployed. So let's just see, highly likely the third one should be kicking in now. Yes. See the third node, you can see that is 17 seconds. It's just actually being configured. It's still not ready, but as soon as it is ready, which should be another few seconds, this pending pod or pending replica should be deployed into that particular node. Let's see what's happening. So that's ready now, and we should be able to see in that case. Yeah, you can see that pending has been changed to pod initializing. So the remaining replica would be installed within the next next 1 minute or so. You can also see here, the 2 has been successfully deployed. This replica is still not deleted. The other 2 has already been deleted because this has been deployed. This will only be deleted after this is deployed. But while that is happening, I think if we try to reach this is not available because the new configuration has taken effect. And I have this custom domain related endpoint configured here or entered here. You send this, see, you can get the response from the application with the new custom domain now. So that's good. We have seen autoscaling and also the custom domain, both covered in that. I'll just take a pause and then any questions, Ashish or Anup, if you can throw it my way.
Yeah, Shefreen, one question just now we have seen. We said like 0 downtime, right? But we saw the response for not 4.
No, that was actually for the, I'll show you. That was actually for the old network load balance, right? Currently, with the new configuration, it's actually the custom domain configured within the Ingress controller. That's why.
So now Ingress controller is getting used inside only, right? After hitting your custom domain, that custom domain is mapped to that Ingress controller. Ingress controller anyway internally it's getting used. Yeah. Okay.
That's right. That's right. So from custom domain, it will forward it to the network load balancer. But within the Runtime Fabric, the configuration is now related to, because we updated the custom domain as the address. So the Ingress resource configuration will only look into a request coming from the custom domain, which is ngclabs.net. So that's why the old one, it's discarding it and
publicly it's not reach. So Vinod had one question, like any documents around choosing the vCore based on incoming traffic and other criteria. I think, yeah, definitely there will be document to decide. Okay. vCore side.
All right.
So, Shefreen, one question from Sanachit itself. So, is there any Kubernetes Helm chart for RTF?
For RTF installation, no, it's not with Helm chart. For all the other, prerequisites I have done, that's actually, also possible with Helm chart. But RTF actually, you have to do it with the RTF-CTL command line utility, but not with Helm chart. Probably, maybe in future, but not at this stage. But I will also, again, recheck on that. But to my knowledge, as of now, it's not there.
So one question from Dheeraj saying, so mapping can be done only one custom domain or multiple?
Multiple custom domains are possible, obviously. So for the demo purpose, I'm just going with, single domain, but yes, multiple domains are possible. And even with the wildcard against each domain, that's possible. So all those possibilities are there.
Okay.
Okay, so this one is done. Now we just have actually, only a couple of them left. Scheduler failover verification. So traditionally, scheduler, how it works is it runs on a primary node. So let's just see if that is the same case in Runtime Fabric. We can deploy an application straight away. I have again a name to track it in the logging framework. Where is the name? Where is the name? Yes, RTF demo scheduler. Deploy it into the EKS. This is actually a very small file because it's nothing actually. What is it? Just a scheduler and a logger, logging the message. So just 1 MB. Easy with that. And Ashish, regarding your question before with regards to the replicas, if you select 3 now, this is actually available now, right? Because if it is 2 or 4, okay, even with 2, it can actually still deploy it across out of the 3 available 2 replicas. But if it is 4, it will be disabled. So 3, 2, it is actually available to select. So we'll go with 3. And again, runtime cluster mode, because if it is not cluster mode, scheduler will run on each and every replica, which is not what we want. That's similar to server group feature in runtime in on-premise. All right, so rolling update, rest everything actually we will keep it the same, just one. And let's just, Ingress doesn't matter here because it's just an internal application. Deploy. What I want to show here is how the scheduler is functioning once we deploy the application, and what will happen in case the node where the scheduler is running that fails. So we will actually forcefully delete it and see if the scheduler functionality switch over to any of the existing replicas. So the application is getting deployed. Any questions in the meantime, guys?
Yeah, I don't see anything.
Yep.
Yeah, I missed a little part where we are deploying the scheduler application in the RTF. So how we're handling that, it should not schedule on all the replicas.
Yeah.
Yeah.
Sorry, was that actually
yeah.
probably
So how we're handling that, the scheduler should not schedule on all the replicas. It should be on like a primary node on premises, right? If you have cluster. So here in the RTF, same way.
That's right. Same. Yeah, same way, exactly same way. Now, yeah, this is actually deployed, and we can see probably from the dashboard here. Refresh. You don't need 2 minutes because that will have too many log messages there. We will just go with 1 minute to see the. I didn't get time to actually filter the messages using Logstash. Otherwise, this would have been much easier. That's why I'm just having to wait for these deployment related messages to flush out. So once that, so this here is the scheduler replica run on this particular port 54NKQ. Let's just refresh again, making sure that in the next instance is also coming here. See this one. So it's always going to run on this specific replica. Now, what we need to do is we will just kill it and see if it actually shift to any other replica or not. So 54NQ, let's just get that from here. 54NQ. So this is the one where it is running. Ideally, it should switch over to either of them, the scheduler functionality. Let's see that. Let me get the command to delete it. kubectl delete pod. So delete pod, you need to actually give the name of the pod, this one, and there was an additional space there, I believe. All right, and then namespace. That should delete that particular pod. And oh, I've taken more than 1 hour. Huh? I just realized I'm just looking at the time now. Sorry, guys. We'll finish this soon. The API manager, doesn't matter. We will cover that. I mean, it works exactly like how it works for Cloud Hub or even on-premise hybrid model. So this one is deleted. Let's just quickly see what's happening here. A new replica has been, created. So this particular one, so the deleted one is gone and a new one has been created. The scheduler should be either running on this one or this particular replica now, port now. So let's just see from the logs. Still some messages to be flushed out, so we'll just give it a while. So meanwhile that gets flushed out, I can look into. So API manager, we will skip this. I'll just touch base upon the TLS certificate and termination options, the last topic. So we saw this diagram before. So this is actually your cluster. You have your load balancer here. You have your ingress controller here. So you have the option to terminate your SSL HTTPS traffic either or the network load balancer or at the ingress controller level. By default, it is ingress controller, but the catch for that is you need to have your own certification manager service to manage that, all the certificate, and you need to install a separate third-party service for the same to manage that. So the other option is you can actually, terminate it at the network load balancer level and have all the traffic within the cluster as HTTP, but the traffic terminating here as HTTPS, SSL termination here. So this one, it was actually a fairly, easy approach because we already have the custom domain and there was a certificate available from the domain from Route 53, and we can just use that certificate and link or associated that with the network load balancer. Now, that's the reason why all our requests, so that has already been configured, and that's the reason why all our requests with the HTTPS traffic, you can see that certificate. There is the certificate already, certificate CN name, issuer is Amazon, valid until. If this has not been done, it would be invalid certificate coming here. So the reason why it's actually, green is, here. The reason why it is green is it's already been configured. The SSL termination has been enabled and it's happening at the load balancer level. Okay, so we should be just good to go for the last section.
Is that happening automatically, Shefreen?
Yeah, see.
Certificate configuration?
Which one?
Okay.
No, you need to configure it, obviously, but it's fairly simple procedure. So you have the certificate available from Route 53, and you actually, get that certificate, configured against your load balancer. There is actually proper. I'll provide probably even the reference for that also in the.
Yeah. So there are two questions. One is pretty simple. Where is the auto scaling configured? So why deployment we give that, right? So that is, I think, Ravi, that is the answer. One question is from Prasad. Is there a way where we can trigger the scheduler as a ad hoc basis in RTF? How we do it in cloud application? I don't think so.
No, I didn't get that question.
I don't think that is possible, I guess, because.
Okay. Yeah, I get that. So in Cloud, when you deploy, the scheduler is actually visible, right? So that functionality is not in Runtime Fabric. So you can't can't do that. So a scheduler, it will be actually running on one of those nodes, and if you define one primary node, it will be running on that, and then if it fails, it does that automatic failover. That's it, and that's what actually we have seen. It actually is some other pod, this 9Q7SJ that has taken over, and then that is actually running all the scheduler functionality. So yeah, that's basically about it from my side. The API manager, like I said, there is nothing different to that. You go to your API manager, and you can apply the policy by selecting the API spec from the exchange, manage the API from the exchange, select one, and then it's the same process. And then I've tested that, and then that should also be reachable once the policy is once the proxy is applied, and then you can, or even with paired auto discovery, and then you can actually apply the policies, rate limiting policy, authentication policy, whatever you want, and it would work exactly the way you would want to. So that sort of concludes my list of topics. Just to wrap it up, so the main focus has been we touch based on overall Runtime Fabric, both flavors, appliance and self-managed Kubernetes, even though our focus and demo has been all around self-managed Kubernetes, and that too specific to Elastic Kubernetes Service. But you can actually deploy a similar way to Azure or Google. And like I said, to get some experience, to to play around, Google would be a good option, because they provide actually, I think, 1 month free credits up to $300. So you can even have master nodes free, controller nodes and all. For 1 month you can actually use even actually decent capacity without paying anything. So yeah, so that's about it. Wrapping up the last topic. Yeah, it's just all the benefits we have mentioned before. Provides cost-effective approach, give more control, offer the flexibility in deployment option, with various managed Kubernetes service providers like GKE, Azure, and AWS. So that's it, guys. That's from my side. Thank you. Any more questions? I'm still here to answer that, but otherwise I think it's going to be a trivia quiz around what we presented, and also I believe some networking time or stuff like that. So over to Anup.
Yep. Thank
and
you.
Ashish.
Thank you, Shefreen. Yeah, just sharing my screen. Give me a second. So yeah, so actually it's a lot to sink in, right? A lot of informations are there. Thank you so much. It's quite evident, like the setup of things is quite it has been difficult, and we understand that there is a lot of work being done for this particular session that you want to provide, right? So I wholeheartedly thank you for that to come forward. Yeah.
Thank you, guys. I also acknowledge just one point to add, because I also think there has been a lot actually packaged, and especially for people with not much of Kubernetes background, it might be a bit hard to sink in, especially the Kubernetes side of things. The RTF and application side of things, that's still fine, but the Kubernetes side of things, it can take a while to get used to it. But otherwise, I think actually this session is of some use, and anybody anyone can reach out to me with any doubts, even in future. I had shared my LinkedIn profile there, so you can actually connect me on LinkedIn, and any doubts related to this, you can reach out to me. And if I cannot answer, obviously we have Bijoy Thomas, my mentor, sitting there. He's actually expert on everything, so he can also
Yeah,
contribute.
that's right. Yeah. So as you said, like you have given us the whole walkthrough, so we have recorded it. We have the video, and you'll be providing us the steps to all the commands to do that, so we can actually try it out. It's not a rocket science anymore. The Runtime Fabric, it's not a rocket science. We can try it out with the Google platform, right? Yeah, so it is very much helpful. Thank you so much.
Yeah. So I think last question is there in the chat. I hope we have not missed anything. Can we apply tokenization policy in RTF with EKS?
What is that?
Can we apply tokenization policy in RTF with EKS?
To my best of knowledge, that is not possible.
I think on Appliance it's possible.
Yes, Appliance it's
policy.
Because they have the security, Anypoint security edge, right? But there should be other custom way of doing it, not from Anypoint framework, but probably from third-party solution that should be available to do that, but not from Anypoint point of view. It's not available out of the box or through security edge, because that's not supported.
Okay, that's pretty much. Yeah, and thanks, Shefreen, for your time, and a great session, man. First time I have attended, end-to-end setup with live demonstration. Thanks a lot for your time.
Thank you. Thanks for that encouraging words. We appreciate that.
Yeah. So before moving to the trivia, you want to? So Anup, it's over to you.
Yeah, so I think we can move to the quiz, and then we'll wind up. So
yeah, guys, please be ready.
Yep. So the quiz, there are like certain rules. So what we are having, like we have questions, and we'll be providing you with options. So what we are going to select, since we have like around 51 members, I'm going to give you 3 questions, and with all the options. So you need to type in the answers in the chat window, and we'll be selecting the first three. For every answer, we'll be selecting the first three, and we'll be using an online tool to spin a
First three
wheel.
correct.
Yeah, first three correct answers. Yeah. 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 So we'll be using a spinning wheel to get the lucky ones out of it. Yeah. So here we go. So open up your chat window and ready. Be ready. So here's the first question.
Just a second, Anu. I'll draw a line there so that people won't get. No, we won't get confused. Okay. So let me draw the line.
Sure.
Yeah. So yeah. This is the
Okay.
line. Okay. Go ahead.
Fine. So this is a first question. So which one of the below self-managed Kubernetes services not supported by MuleSoft Runtime Fabric at this point? So here are the options. Google Kubernetes Engine, Red Hat OpenShift Managed Services. So don't provide A, B, C, D. Provide the whole answer so that we can get the right one out. Yeah.
I think this is also fine, Anu.
Okay.
Yeah. So Shefreen will tell the answer. What is the answer, Shefreen?
I think it's sort of evident. So yeah, everyone has answered the same Red Hat OpenShift Managed Services. Just on that, I think that's in the pipeline, probably in the next quarter or something. That support is also coming, but at this stage, that's not supported.
Yeah. So Anup, can you note down the name? I'll read it for you. Chala Ravi is the first one.
1 second. Okay. Chala Ravi. I got it. Then
Madhava. And Atul. Yes. Atul Mahale. Yeah. Just say Atul.
Yeah. Okay. Got it.
So guys, now these three guys we are not going to select in the next question. Okay. So even they are in the top three, we are not going to select this. Okay. Yeah. Go ahead. Second question.
So which feature below is not included or supported by RTF?
1 second. Just before sending the question answer, let me draw the line. Yes, go ahead.
Yeah, so which feature is not included, supported by RTF on self-managed Kubernetes? So options are below. We discussed this today now in the session.
Yes.
Okay.
Yeah, so what is the answer, Shefreen? We are confirming from your side.
I hope I don't get it wrong. Anypoint Security Edge.
Yes. Okay, so yeah, Ravi Teja,
okay,
Hitesh, and Aditya.
Ritesh.
Yes, Hitesh.
Hitesh and Adityan.
Yes, Aditya.
Okay, got it.
Let me repeat: Ravi Teja, Hitesh, and Aditya.
Hitesh and Aditya. Okay, fine.
Yeah.
So the last, you can draw a line.
Yes.
So the last question is specific to Coimbatore because it's a general question. It's not related to anything related to Kubernetes. Okay. So it is specific to Coimbatore people. I mean, whoever can answer it, but yeah, it's. So since we are having this Coimbatore meetup, like we thought like we'll give them a preference. So what is the nickname of Coimbatore, or what it is popularly called as? Okay, so here are the options. Gateway of South India, Handloom City, Manchester of South India, Cultural Capital of South India.
You have to give the answer, Anup, now.
Okay. Yeah, it's a Manchester of South India. Yep.
Yeah.
So that's great.
So yeah, Dheeraj. I can note down Dheeraj.
Yeah, Dheeraj. Yes.
Chala, we are skipping Chala. Then
Chala Ravi, I think it's yeah, okay. Then
Chala already there.
Yes.
Anand Joshi. Anand. And then we have Vinod. Yeah. Then we have Vinod.
Vinod.
So Dheeraj, in the last question, Dheeraj, and then Anand, and then Vinod. Okay.
Yep. So give me a second. Let me set up this thing. Spin wheel. Okay, so I think it's there. So let me add up the names. So it's Chala Ravi, Atul, then Ravi Teja, Hitesh, Aditya, Dheeraj, Anand Joshi, Vinod.
Yeah. So whoever is the winner, okay. So please, give your email ID in the chat window. Okay. So top 3 will take your email IDs, and then after that we'll share the next step. Okay. Yeah. Shuffle it, Anu.
So the first, yeah, first one.
Madhava. Congratulations, Madhava.
Yeah, Madhava, yeah.
Remove it from there. Remove from the list.
I'll remove him. Let's go once again.
Ravi Teja. Ravi Teja superstar.
Hi Ravi, congrats. So one more
Congratulations,
time.
Ravi. Aditya. Congratulations, Aditya. Please share your email IDs here, please, guys. So first one, Madhava, and then
Ravi Teja and
Teja.
Aditya.
Please share your email IDs in the chat window or directly message to Anu.
Yep. So what's next? So tag us using MuleSoft meetups in Twitter and LinkedIn. Okay. Then again, as always, like join our group, and so you'll be seeing more interesting things coming in next few weeks. So these are the interesting things. So we have our own Shravan and Jitendra presenting in on 24th and May 8th, and we have Ashish, our organizer, also presenting in May 15th. So on one is on understanding error handling part, one is dynamic client registration using Okta OpenID, and other is API complete life cycle with API security. Okay, do register for us. This is important, so please provide your feedback, whether it is positive or negative. It is a motivation for us, so please provide your feedbacks to meetups.mulesoft.com. It will help us to provide you more quality content and deliver, like improve on ourselves, right? Okay, so that's all pretty much we have here.
Yeah, and guys, if you have any specific topic, you can suggest us, or if you want to want to present your own topic, please message us or contact us. We are there on the LinkedIn. Okay, and if you have any questions related to this topic, Shefreen already shared the LinkedIn profile details. We can reach out to you. Okay, if you have any questions, you can post to us. We can get the answer from the experts, and then we try to reach out to you guys. Okay, and the slides and the references and the commands will be uploading to the Meetup's site. Okay, yeah, please go ahead, and yeah, you can. So Anu, you noted on the email ID, right?
Yeah, so one more to get. So Madhava, I've noted down. Aditya, I'm done. So one more. Vinod, I need to get Vinod. Did I miss
think
Vinod?
it's Ravi, right? Third.
Yeah, Ravi Teja.
No, Ravi Teja. Sorry.
Yeah.
Ravi Teja, can you provide your email address?
Hey, Ravi, are you there?
Yeah. Okay. I got it.
Okay. Yes, congrats to all winners, okay? And we'll be reaching out to you guys with the details, what next we need to do. Okay. Yeah. And Shefreen, thanks a lot. Thanks a lot again. Okay. Thanks for the
everyone.
time.
Thanks a lot.
Yes,
Thanks for the question.
Yeah.
Yep.
So we
Thank you.
conclude. Yeah. Thank you all attendees, and we're concluding this session here.
Yep.
Sure.
Thank you all. Thanks, Vijay.
Thanks, Vijay. Thanks.
Thank you, Ashish. Yeah, well done, Shefreen. It was good one. Yeah.
Thank you.